Welcome folks, and welcome to our video on counting atoms. And so the process of counting atoms can sometimes be confusing because while atoms are all around us and there's millions, billions of them, a little bit more complicated than counting fingers on your hand. So how do you actually count or record atoms? Well, it can seem like there's an overwhelming amount of atoms, sort of like the locusts in the picture here, but how we do it is we focus on a small number of molecules and the ratios within those molecules. So similar to counting peas here, we break it down into one or two molecules and we focus on those ratios. So let's just go back and review what we already know about compounds. So compounds are pure substances that are made up of two or more elements in specific ratios or definite proportions. So those ratios, they don't change. If they change, it's a different compound with different properties. And so similar to the Lego that's on screen, you can see there's a ratio of red to white, and the ratio of white to red rather is 2:1. And in a similar way, compounds are made up of specific ratios, and that could represent water, 2 hydrogens and 1 oxygen, that Lego model. So compounds are always molecules and the atoms are held together by strong bonds. In our Lego example here, it would be the sort of stickiness of the Lego together. And another example here would be NaCl, salt, sodium chloride. You can see the ratio is different there. It's 1:1, so that would be the ratio. And compounds are written as formulas. So we can see again, this time we're focusing on water. We're looking at a different type of model, but we can see that the ratio in the circle is H2O. Its ratio is 2:1, 2 hydrogens and 1 oxygen. So let's start. Oh dear. Not so much OMG and more like MgO. MgO is magnesium oxide. It is a white powder that's used in health supplements and health stores is where you would find it, a granular white powder. And if we look at MgO, I guess what's important here is it's magnesium and oxygen together. And every capital letter means you start with a new element. So this MgO is not 3 elements, rather 2. So there's only 2 capital letters, so 2 elements, so Mg and O. Another example would be sodium fluoride. We have the NaF, where we have 1 sodium and 1 fluorine. You're not to go to a periodic table and look for N and then A and then F, because there's only 2 capital letters. That means there's 2 elements essentially. And just a little bit of a recap, how does that even happen? We start with our sodium in blue. It has 1 valence electron. It will lose that to get a full outer shell and be more stable. The fluorine will happily accept the electron. They get a charge and then they bond and stick together. So we have our compound formed, 1:1. Second thing we should talk about is this notion of a subscript. Now subscript, sub in English means below. So a subway is something that is below ground, or sub-zero is something that is below 0 temperature wise. So a subscript in this case tells you the number of atoms of each element, and a subscript here is something that is written below the line. So in this case the subscript is 2. And it tells you the number of atoms of each of those elements. So in this case, the 2 belongs to the hydrogen. It's always belonging to the letter or symbol that it's after. And so it's 2 hydrogens. And there is no subscript in oxygen. So we have to assume that there's just 1. The fact that O is written there means there is at least 1 oxygen. And if you don't see a subscript, it defaults to 1. So there's 1 oxygen. Sweet. More examples? Well, how about something really sweet like sugar? So it looks like it's complicated here, C6H12O6, but we can break that down. So it has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Oh, Dios mío. It has a lot. It is quite a complicated molecule. but it brings so much joy to our lives if handled in moderation. What about subscripts outside brackets? Well, similarly to mathematics, you would have to apply that to everything inside the bracket. So it multiplies all elements inside the brackets only. So if we look at this example, which is magnesium phosphate, it looks very complicated at the beginning, and I guess it is. But what we've got to remember is that this 2 outside the bracket, it multiplies by everything inside the brackets. Okay, so it multiplies by the phosphorus and the oxygen, not the magnesium, because that's not in the brackets. So what we end up with here is 3 magnesiums, 1 multiplied by the 2 outside the brackets of phosphorus, so 2 phosphorus overall. And then we take those 4 oxygens and we multiply it by 2 to get 8 oxygens in total. So subscripts outside the brackets apply to everything inside the bracket. And what's essentially happening here is that this Mg3PO42 is actually written like on screen here. There's 3 Mgs, and what it means is that this PO4 is double. There's 2 of them. That's essentially what that means. So let's do a little bit of practice here. I want you to stop the video and see if you can figure out how many atoms in total is in carbon dioxide, CO2. Well, the CO2, there is no subscript here on the carbon, so that would give us a value of 1. There's 2 attached to the oxygen, so that is 2, and that gives us overall 3 atoms, 1 carbon and 2 oxygen. So I would like you to pause the video and try and work out how many total atoms there is in each in this, which is sulfuric acid, and also how many atoms of each element there is. So we can see that there's 2 hydrogens. There is actually 3 elements, H, S, and O, 3 capital letters. So there's 2 hydrogens, there's 1 sulfur because there's 1 defaulted, and 4 oxygens. And finally, if you can pause the video again, a little bit of a harder one here. This one is lead nitrate. So pause the video and see if you can figure out for each individual element and then in total. So if we break this down, one of the biggest mistakes I see students make is they apply the 2 to the lead. Don't do that, please. It's only everything inside the bracket. So the lead will have, it has a default 1 here, which isn't always written, but 1 lead. Nitrogen is going to have 1 multiplied by 2, so it's got 2. And oxygen is going to, the oxygens are 3 multiplied by 2, which is 6. So we have 1 plus 2 plus 6, which is 9. So I hope this video has been useful and helped you in terms of understanding how to count atoms. If you enjoyed the video and found it in any way helpful, please remember to give us a wee thumbs up.